One first thing you want to make sure about access points is that you can access your access point CLI, if only that, to run show commands, if not debug commands. So look at this, I'm typing an admin username here at the access point CLI, and when I type Cisco, it works, but admin something didn't work. So default is Cisco, so you might find it normal that Cisco works, but it's not always the case. And by the way, the default for enable is also Cisco. But if you go to your controller and if this AP ever joined a controller, you might have changed the defaults. And you can change them in two places. First, of course, is the at access point level. If you go here and go to credentials, you can use this checkbox, override credentials, to change the username and password used to go for that AP. And the thing is that the AP is going to remember that change. So next time it reboots, even before it joins this controller, it's going to remember those changes. So you may be in a case where the AP is not accessible anymore because you changed the username and password here, but you didn't know. You did, or somebody else did. The AP rebooted. It's not on this controller, but still you cannot access the CLI. What do you do in that case? Well, the best case, if you do not want to reinstall the AP firmware, is to get the AP somewhere on the controller and then go back to that page, change those values. Because you know the AP is going to use CapWap to join the controller, so it doesn't need those credentials. So the safe way is to have the AP on the controller so that you can cleanly change those credentials. So you can set the credentials at the access point level, but you can also change them globally on the controller for all the APs that are going to join this controller. And this is done here in wireless, access points, global configuration. Of course, if you change the value here, all the APs on the controller are going to change their username and password from Cisco to whatever you put here. And they are going to remember that as they reboot. If you make a change here, and you also go to the individual access point and you make another change, as usual, it's the change specific to the access point that is going to be chosen. So if you say here admin, and on the access point you say test, you're going to use test on that access point and admin on all the others. So again, best way, if that happens, get the AP on the controller. Put the controller in the same subnet. That's a guarantee that the AP is going to broadcast CapWap discovery messages, and it will eventually get on that controller. You'll be able to change its value. Okay, now on the access point, there is a very nice command if you can get access to the CLI, which is show CapWap client RCB. Don't ask me what RCB stands for. But that command is great because it's going to tell you what is the CapWap status of the access point as a client. It's going to tell you that the AP is enabled, which is great, but also it's going to tell you the MWR. That's the main controller. That's the controller to which the access point is connected. So you see now it's on WC30, and you see the IP address, the management IP address of that controller. When the AP is not connected to a controller, it will tell you as well. It will tell you I'm in discovery mode, I'm in join phase. It will tell you exactly what it is doing and where it's doing it. So if you happen to connect to an access point and you don't know where this AP is, just that command tells you on what controller the access point is. It also tells you the access point mode, local. That is very useful if you get the AP in some weird mode like bridge, for example, where you may remember you need to put the access point MAC address in a MAC filter. So that is useful to know what exactly the status of the access point is. And of course, below you have some other hardware characteristics that are not as important for the CapWap phase. There is another one which is show CapWap, and if you continue, you can choose, for example, IP configuration. This is interesting when you want to configure the IP statically to join the controller. You can give an IP address to that access point, and you can also provide a specific configuration to the access point about what controller it's supposed to join. So this family of show CapWap command is very useful to let you have a view of what exactly the access point configuration is as a CapWap client. So for example, the show CapWap client config is going to tell you if you have a primary, secondary, tertiary controller configured on the access point, what the IP address of the access point is again, what its mode is again, but you see you have a different view from the CapWap standpoint about what the access point status is going to be. And of course, because it's a Cisco object, show CDP neighbor is very useful for you to check what is next. That is to say, what switch port the access point is connected to. More than often, when the access point cannot join the controller, it's because it cannot get an IP address or because it cannot route its way to the controller. So with show CDP neighbor, you can check what switch the access point is connecting to, and that will allow you to check on that switch what the configuration might be and what connectivity might be as well. So here I'm on my switch, and I can say show run for the interface on which I know the access point is connected now, and that allows me to know if it's a trunk or not, if it's a VLAN or not, and what VLAN is allowed there. The other important thing you can run on a switch is show power, because the access point can either have a power brick or it can use PoE from the switch. And show power in line on the switch is going to be very useful to know how much power is being drawn from that port. And you see here, my EP is taking 11 watts. It can get all the way up to 15.4 watts. That may be good, that may not be good. Depending on the access point model you run, it may need 802.3 AT, which delivers up to 30 watts, and that configuration about 15.4 watts may not be enough for that access point. But here, if you see my access point model, it's a 702W, and that 702W doesn't need more than 802.3 AF, which is 15.4, so we're fine here. Also, if the AP is in a VLAN, you may want to check that VLAN status at layer 3, so show IP interfaces brief to check, in my case, that VLAN 23 is configured and is up. So I know that my switch is a layer 3 switch and it can route traffic coming from VLAN 23 to somewhere else. In the same logic, if your switch is a DHCP server, you may want to say show running config beginning with the IP DHCP service configuration for that subnet, just to check that there is a DHCP scope running, and if it's an access point port, maybe that there is an option 43. And maybe you want to translate that hexadecimal value from hex to decimal to verify that you are providing the IP address of a controller that exists and can respond to the access point. Obviously, ping, right? Layer 3 test, that's something you can do from the access point CLI. You should be able to try to test connectivity to the neighboring switch, the gateway, and of course to the controller. If you can ping the controller, then there is connectivity and the AP should be able to join unless something more complex happens. On the controller side, there is a nice command. There are a lot of debug commands, and you should not need to know any debug command for the CCNA wireless exam, but for your everyday life, there is a very nice debug on the controller side on AirOS, which is debug capwap. And here you have a few options. One is simple, it's error, and you say enable. So it's only going to tell you about capwap that went wrong. Be careful, you can use a lot of debug capwap commands, but the error is probably good enough for you to only get when it's a problem and not get everything else, which may be overwhelming. So if you look here, my access point is not joining my controller, and you saw my test. I could ping my controller from the access point. I have connectivity to my switch, it's getting an IP address, and if you were to translate my option 43 hexadecimal value, it is pointing to a controller that does exist, yet there is no join on this controller. So what's going on? If I look at my message logs, I get a weird message that says DTLS handshake with peer blah 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 failed. So that is something that you may see very often. This is why I would like to focus on this example. So DTLS handshake failed. That means that if you remember in the phases of my access point join, there is a discovery phase where we have a capwap exchange of discovery and response for the discovery. And then there is a join phase where there is a DTLS tunnel establishment. And this is the phase that seems to be failing. So of course, if the AP fails the DTLS negotiation, there is no way it's going to get its configuration from this controller because it cannot join it. Why would a DTLS exchange fail? Well, primarily for one reason, certificate exchange. That is to say, the certificates that are exchanged between the access point and the controller do not work. One side is refusing it. And if you think about it, you could not think of any reason why that would happen. Those certificates are not certificates you change or you put. There is no PKI here, although there are some ways of getting certificates on the access point and the controller. But for the AP to controller communication, those are certificates that were put in factory by Cisco. So they should be recognized on both sides. Or maybe not. Apparently not. So let's dig a bit further. While I was looking here, my debug capwap errors enable command was in effect. So I do have some errors reported for capwap on my CLI. So what do they say? They say handshake or DTLS encrypted packets failed. So it keeps saying that the negotiation for DTLS fails. All right, and if we look at the access point, you see what we have here. It says, oh, look at that, certificate unknown alert. So the access point is telling me that the controller is sending a certificate that is unknown. So again, if you think about it, you say, well, that's not possible. It's been by Cisco implemented into the controller and I cannot change it. So why would a Cisco certificate be not valid? Well, that issue, which is very common, is in fact due to this. Look at the date on my controller. It may happen that there is a power cut and that the battery on the board of your controller is dead for some reason, which means that when the controller reboots, it goes back to its default time, which is somewhere in 2000. So when that happens, of course, the access point cannot join the controller anymore because the controller is sending in 2000 a certificate that was probably created somewhere in 2015 or 16. So that certificate is going to be created in 15 years. There is no way it can be valid. So the AP is refusing the certificate because the certificate is not valid yet. And that is key because the access point is getting the time from the controller. The access point adjusts its time when it talks to the controller so that there is no issue in the DTLS establishment between the AP getting its time from some place and the controller getting its time from some other place. So the AP is going to adjust its time from the controller, and therefore the controller certificate created in 15 years is not valid yet. That is a very common issue, and that's why I wanted to give you this time issue as an example in the access point section. So you go here, command, set time, change, and put in a date that is something closer to the date where you're running this troubleshooting exercise. It doesn't need to be the right year, doesn't need to be the right day, as long as it's something which is in the validity scope of what is possible for a controller, then it's perfectly okay. Once this is fixed, of course, you have to re-log in into the controller because now you've jumped 15 years ahead, right? But once you do that, you should see after a while that the access point is going to join. If you use an NTP server, you can also go here into controller, NTP, and you can define an NTP server. It's actually a good idea to do so. And then here you just enter the IP address of your NTP server, and you also have the option to use authentication if your NTP server uses authentication. So now my date is back to something that can make sense possibly. And if you wait a few minutes and if you keep looking at the console, you should see that the access point after rebooting, trying again, should probably make it to the controller now. Here we go.